Well, if you've clicked on this video, then like me, you are a complete and total ultralight backpacking nerd. Enjoy! There is currently a great deal of discussion regarding the techniques used to create Cuben fiber tarp tieouts. Some companies are using bonded methods, while others are sewing them, and then some are using a combination of the two. Some recent posts online, and my own experience, have led me to do some formal testing to see if there is a large difference in strength between several of these techniques. Will a sewn tieout fail with much less of a load when compared to a bonded tieout? Is the additional time required to bond the tieout reinforcement patch worth the effort? Is it beneficial to use a heavier Cuben fabric for the reinforcement patch? Let's try to answer these questions. The purpose of this experiment is to test various tieouts, manufactured using materials that the typical person can easily purchase and acquire, used on a Cuben fiber tarp. The goal is to give a general idea of the strongest and weakest joint designs. The procedure is as follows. Using a combination of bonding and sewing, 5 typical tieouts, samples, were created. Each tieout was then placed into a jig and loaded using a tensioning device until failure. Below, you can see the dimensions of each sample. Each of the samples utilized the same materials. Cuben fiber DCF CT2K.08 with a 5/8 grosgrain tieout. In each case, the 5/8 grosgrain was sewn to the tarp tieout, with the only difference being how the patch was attached to the base fabric. The 5 different attachment styles for the patch were sewn, 3M 9485 PC, Hysol U09FL, Venture Tape 1163 MS74, and Quest Outfitters Cuben double-sided tape. The samples were then loaded in the test setup pictured here. At the top, the clamp assembly. Just below that, the tieout sample. At the end of the grosgrain tieout, a scale is placed. And at the end of the scale, a tensioner to a fixed bar. As the tensioner is loaded, the scale will indicate the amount of force before a failure occurs. You will notice here that the test jig is a highly specialized assembly of old 2x4s that I found in my garage. In sample 1, the reinforcement patch was sewn to the parent material, and the grosgrain was then sewn through both pieces of Cuben fiber. Yielding was not documented on this sample, as there was no indication that the failure was about to occur. The sample snapped in a catastrophic manner at a max load of 168 pounds. Here you can see an image of the failed tieout after it was removed from the test setup. In sample 2, the reinforcement patch was bonded to the parent material using 3M 9485 PC tape, and the grosgrain was then sewn through both pieces of Cuben fiber. Yielding began at roughly 150 pounds. This was initially heard as the material began to stress. Shortly afterwards, the sample snapped in a catastrophic manner at a load of 178 pounds. Here, you can see an image of the failed tieout after removal from the test setup. For sample 3, the reinforcement patch was bonded to the parent material using Hysol U09FL adhesive, and the grosgrain was then sewn through both pieces of Cuben fiber. Yielding began at approximately 190 pounds. This was not confirmed through visuals, but the sound indicated severe stress. The sample snapped in a catastrophic manner at a max load of 211 pounds. Here, you can see an image of the failed tieout after removal from the test setup. Sample 4. The reinforcement patch was bonded to the parent material using Venture Tape 1163, and the grosgrain was then sewn through both pieces of Cuben fiber. Yielding was not seen in this sample. The parent material split at the max load and the test was stopped at approximately 190 pounds. Here, you can see an image of the failed tieout after removal from the test setup. Sample 5. The reinforcement patch was bonded to the parent material using Quest Outfitters double-sided Cuben fiber tape, and the grosgrain was then sewn through both pieces of Cuben fiber. Yielding was not seen in this sample. The grosgrain tore off the corner tieout and ripped the parent material simultaneously at a max load of 200 pounds. Here, you can see an image of the failed tieout after removal from the test setup. A summary of the results were gathered and tabulated for easy comparison. I'm not going to read through all the information, so if you want to take a closer look, just press pause on the video. It's important to identify any sources of error. In my opinion, there are 3 contributors to error in this test environment. 1. Each test was performed only once. Therefore, there was no average obtained. 2. The scale used in the test setup was not calibrated. 3. The sewn areas of the samples were not monitored for identical manufacturing techniques. In conclusion, it can be seen that the strongest tieout was the sample with the reinforcement patch bonded using Hycel U09FL, followed by the Venture Tape 1163 MS74, Quest Outfitters Cuben Fiber Double-Sided Tape, 3M 9485 PC, and lastly, the fully sewn sample. In all samples, the failure was not on the reinforcement patch itself, nor was it in the threads of the grosgrain tieout, except for sample 5. It occurred in the parent material of the tarp. Sample 5 differed in that the threads of the grosgrain actually ripped out of the reinforcement patch, as well as the parent material failure. Under closer inspection, the Cuben fiber double-sided tape offered by Quest Outfitters is of substantial thickness when compared to the other bonding products. This could be a contributing factor to this behavior. For the manufacturing of a single tarp, using Hycel U09FL may seem like the obvious answer due to strength. However, one must also understand the difficulty and length of time required to apply the adhesive to the fabric. The Hycel is the most difficult to apply, while any of the tapes are quite easy. The sewing is probably the fastest due to the fact that you are not adding any additional processes to the tarp, just cut and sew. When looking at the failure loads themselves, it appears that all of the techniques are adequate for general use. The weakest tieout, sewn, holding 168 pounds, in my opinion, is a force larger than what I would see on a typical tarp camping trip. I have no calculation to support this, however. This becomes even more apparent when you compare the percentage values of each sample. The difference between the strongest, 211 pounds, and the weakest, 168 pounds, tieout samples is only 20%. Is an additional 20% of strength required? That will depend on each individual's conditions and tarp pitching skills. When questioning whether or not a heavier Cuben fiber fabric used as a reinforcement patch would increase the strength, it is important to remember that the failure occurred in the parent material. This is an indication that a heavier Cuben fiber material may not increase strength by a substantial amount. However, testing would need to be done to verify this.